In this capstone, we turn requirements into a governed AI architecture. The goal is to connect risks, controls, owners, and evidence, so the solution is not only well designed, but ready to support ISO IEC 42001 certification. Before we build the capstone artifacts, let's connect the full journey. We've covered ISO IEC 42001 foundations, governance and risk practices, architecture patterns, operational controls, and certification readiness. Now we apply those pieces to the case study by turning requirements into control mappings, ownership, and evidence. A governed AI architecture does not start with technology. It starts with requirements. Business goals, regulations, risk concerns, and system needs are analyzed together to clarify the AI purpose, users, context, and decision impact. From there, requirements become design constraints. What data can be used, how models are managed, how GenAI is monitored, and who has access or oversight. The key ISO IEC 1420 discipline is traceability. Every major technical component, governance process, and evidence-producing activity should connect back to a risk, policy, control expectation, or stakeholder need. To design the right controls, we first need to know what we are governing. The architecture boundary defines what sits inside the AIM scope: the AI system, datasets, models, APIs, user workflows, and supporting processes. It also names what sits outside, such as cloud platforms, third-party models, data providers, vector stores, and monitoring tools. The key governance question is where risk crosses a boundary. Each interface should show responsibilities, assumptions, exclusions, and contractual dependencies. That prevents gaps during audits, incident reviews, and supplier assessments. Data governance should be built into the pipeline, not added at the end. As data enters, sources are validated, classified, and tied to lineage. During processing, quality checks look for missing values, accuracy issues, bias, and drift against baselines. In storage, privacy and security controls enforce minimization, masking, encryption, retention, and access limits. When data becomes features or retrieval content, approvals and permitted purposes matter. Monitoring then turns activity into evidence. Lineage records, quality reports, access reviews, and audit logs that show the data environment is controlled. The model lifecycle also needs a controlled path, not a one-time build. Teams begin by experimenting and training with governed data, code, artifacts, prompts, and configurations. Validation tests performance, safety, bias, and fit for purpose, producing model cards and validation reports. Before release, an approval gate confirms evidence is complete and risks are accepted. Deployment moves the model into production, where monitoring tracks drift, quality, usage, and incidents. Those signals drive retraining or improvement, and when a model is no longer appropriate, it is retired with archived records and version history. Generative AI needs controls around the full interaction, not just the model. Start with inputs, approved prompt templates, version history, sensitive data checks, and defenses against prompt injection. Then govern what the model can use as knowledge. Retrieval should come from curated sources, refreshed indexes, governed embeddings, and traceable citations. After generation, apply output safeguards such as filtering, confidence signals, safety tests, and human review when decisions are high risk. Finally, keep evidence. Prompt libraries, evaluation results, RAG logs, red team findings, and provider assessments help prove the system is operating responsibly. A governed AI environment needs more than a login screen. Access should match the role, the asset, and the risk. Data scientists, engineers, validators, business owners, operators, and auditors should not all hold the same powers. The key control is separation. The person who builds a model should not independently validate it, approve its release, and operate it in production. Security then wraps the chain with encryption, secrets management, secure APIs, vulnerability controls, and supply chain checks. Every privileged action and exception should leave evidence, so accountability is provable. Effective oversight is not a final rubber stamp. It begins by identifying the decision points where people must review, override, escalate, or validate an AI recommendation. To make that review meaningful, users need transparency. What the AI did, its confidence, rationale, data sources, limitations, and when it should not be used. Explainability should scale with impact and risk. Low-risk decisions may need a simple reason, while high-risk decisions require deeper evidence. Reviews, overrides, disclosures, training, and feedback should be captured so accountability is traceable and improvable. After deployment, assurance becomes continuous. Teams watch whether the model is still accurate, whether incoming data has shifted, whether fairness indicators are changing, and whether the service remains available, fast, and secure. Good monitoring turns those signals into thresholds, alerts, and escalation paths, so teams know who responds and how urgently. The important part is closing the loop. A warning may trigger incident response, rollback, retraining, risk reassessment, or management review. Dashboards, alert histories, evaluation reports, and corrective actions then become evidence that the system is being governed, not simply observed. Governance has to keep working after launch. Every operational change, from a model update to a prompt tweak, should follow a controlled path. Request, impact assessment, approval, implementation, validation, and documented closure. Incidents need the same discipline, with AI-specific categories such as harmful output, privacy leakage, drift, bias, compromise, or misuse. Each event should connect to root cause analysis, corrective action, renewed risk assessment, and stakeholder communication. Tickets, incident records, rollback logs, and post-incident reviews become evidence that control was actually exercised. The traceability matrix is where the AI management system becomes auditable. Start with each risk from the requirements work and impact assessment, then map it to the ISO IEC 42001 control themes that reduce or monitor that risk: governance, data, model lifecycle, security, transparency, monitoring, and incidents. Next, connect those controls to real architecture components, operational processes, accountable owners, and concrete evidence. The status column matters because it separates planned intent from implemented and verified controls. By the end, every major risk should have a clear control path and proof behind it. Controls only work when they land somewhere concrete. For data, connect requirements to ingestion, storage, lineage, quality checks, privacy controls, and retention rules. For models, tie controls to lifecycle stages, such as validation, approval, deployment, monitoring, and retraining. For GenAI, include prompt management, RAG governance, guardrails, provider oversight, and output review. Then assign accountable owners. Architecture may own patterns. Data governance owns data rules. ML engineering owns pipelines. Security and compliance validate risk. And operations keeps controls running after release. Certification-ready evidence is more than a folder of policies. It must show the control lifecycle in motion. Design evidence proves the control was planned correctly. Architecture diagrams, inventories, data flows, risk assessments, and mappings. Implementation evidence proves it was built and approved. Model cards, test results, validation sign-offs, access settings, and deployment records. Operational evidence proves it keeps working. Monitoring, incidents, change logs, access reviews, feedback, and corrective actions. Every artifact also needs version control, ownership, timestamps, retrieval, and linkage to the traceability matrix. The main checkpoint is this: certification readiness is not created after implementation. It is designed into the architecture. A governed AI solution should connect pipelines, lifecycle controls, safeguards, access, monitoring, oversight, and support to specific risks, ISO IEC 14001 controls, owners, and evidence. Next, you will assemble these outputs into a Capstone readiness package for audit-style review.